Welcome to our channel. In this series, we will discuss valid parenthesis in this session. First, read the question carefully. What is a valid parenthesis? Given a string S that containing just the characters brackets. Determine if the input string is valid or not. Now remember, according to the question, the string only consists of brackets, three types of brackets. And when you say that the string is a valid string, the open brackets must to be closed by the same type of bracket. The meaning is, if you open this one, you must and should close this one. If you open this one, close this one. Open this one, close this one. So same type of opening and closing, then it is valid. Another, opening brackets must be closed in the correct order. What is the meaning? For example, this is the string. You need to close in this way only. First, this is closed, and then this is closed, and then this is closed. This is valid. For example, if you written, this is invalid, or else if you written, this is invalid. You got it? So the opening and closing order must be maintained. Now, every close bracket has corresponding open bracket of same type. So, whatever the closing, same type of opening is also required. In this case, the string is valid. Suppose, see this one, the output is true. See this one, opening, closing, opening, closing, opening, closing, the output is true. In this case, the output is false. Okay. Now, if this is the string, what is the output? The output is true. Now, we will discuss how do we solve this one. Read and understand the question carefully. By understand the question, immediately one point. While traversing the string, whenever opening occurred, corresponding closing needs to be present. How the system know this is the opening and this is the closing? That is how the system know this is a pair, this is a pair, this is a pair. For that identification, my first step is I create a dictionary such that one is marked as the key, another one is marked as the value. Suppose I created a dictionary. Suppose closing is the key, opening is the value. This is a pair. So while scanning by using the dictionary, I am identify the correct matched one. Suppose this one, colon, this, comma, closing. This is the dictionary close. So one dictionary is created, which is used to create pairs. Now what is the procedure? Scan letter by letter. That is, scan one character by one character. At any point, if opening occurred, what you need to do? You need to check until close. So here what I am doing is, I am using one empty list. My concept is very simple. If a opening bracket occur, the openings are placed in the list. Whenever closing occurred, remove the last inserted opening and check the corresponding closing. Now I will show you, see. Now an empty list is created for I in S. Understand? Suppose this is my example string. Assume this is your example string. For I in S, initially what is I? According to this example, this is I. Now check whether it is opening or closing. How do you check whether it is opening or closing? So if it is present in the dictionary, means that is closing. Sir, dictionary openings are also present. Remember, we are checking only the keys. Only the keys. Values are checked based on the keys. So, here I written the logic. If I in D, yes or no? If I is present, according to my example, this is I. I is present in the dictionary. The meaning is it is a closing. We are doing some operation. For example, assume the condition false. The condition false in the sense my character is a opening. What you are doing? Simply append operation ld dot appendify. Now, what is my list? My list consists of only single element. Move to the next iteration. In the next iteration, I value is this character. For I in S, I is equal to this. If I in D present, I is present or not? No. Only keys are compared by default, not present. We are moving into else. L dot append. Append means always adding at the end. So this is already first one element is available. You are adding the second element, close the list. Again, in the next iteration, what is the value of I? My example, this is I value. Again check. If I in D, yes or no? No. I is not present in D. Simply what I am doing? Append. Now you got it? Not only this order, whatever the order, if it is opening, I am appending into the list. Now, in the next iteration, what is I value? This one. Now understand. If I in D, I is present in the dictionary, yes or no? Yes. It is present in the dictionary. Now, what you need to check? You need to remove the last element from the dictionary. Why only the last element? To maintain the order. Whatever the opening, the last inserted the corresponding closing. Now that is the reason within the loop what I am doing? L dot. What is the function? For adding at the last, the method is append. For removing at the last, method is pop. L dot pop. Suppose some variable x is equal to. Now, what is x? X consists of this one. From this, this is removed. Pop means removing. I think everyone clear? Why I am using popping? To maintain the order. What is the next point immediately? So I got closing. From the list, I am getting opening. Next one is this is a pair or not. How do you check this is a pair or not? I know I value as a closing. What is D of I? Opening. So immediately I am checking one condition. X is my opening is compared with D of I. So here in my example, X is equal to opening flower bracket. D of I is equal to opening flower bracket. If any case not equal to, no need to check entire string. If in one case, if it is not equal, we are returning false. One case it is not equal, we are returning false. So in this example, it is okay. Next iteration, this bracket. So again, L dot pop, we are getting this one. Same, both are compared. Everything okay. Next to this one and this one. Again, no problem. We are coming from the for loop, but you are not returning any value. You are not returning any value. Now the list is empty. List is empty means what is the answer? False. List is empty means it does not consist of any element. Now, by coming out of the loop, I return not L. That means list is empty means the output is false. Not L means the output is true. Not L means the output is true. This is the logic. Not only this one. For example, assume this is my example. What happened? First, in the list, this element is stored in the list. In the next, this element is stored in the list. Whenever this bracket occurred. Now observe x is equal to L dot, x is equal to this opening, x d of I value is for this is both are not matched, return false. Now, in the time of removing, for example, if this is the case, assume if this is the case, the list does not consist of anything, but you are trying to pop. List first closing occurred, the list does not consist of anything. So, see this one, for I in D, yes, this is present in D, but you are trying to pop an element from the empty list. In this case, we are doing the operation if L. Suppose if the list consists of an element, then only you are removing else. Suppose use some symbol. Not only that one, any symbol means there is no element. X value is hash. That is my concept. Now I will move. Now implement. What is my first step? My first step is you need to create one dictionary. Yes, I am creating a dictionary. So how do I create the dictionary? Closing, corresponding, open. First pair, comma, closing, colon, opening. Second pair, comma, next to brackets. Why I am used right one? So to identify the corresponding left parenthesis, a dictionary is created. What is the next step? I am creating an empty dictionary. Each and every iteration take one value and we are checking in D. In D means whether it is a open or close. If it is close, you are not doing anything. If it is open, we are doing one thing. Suppose if it is pass, I used the statement pass, yes, means my scanned character is open. I am doing append operation. Okay, clear? Now, if it is closed one, your aim is remove the last one. Why only remove the last one? According to the question, you need to maintain the order. So here I will write one more condition. Why? Suppose the string in the first time only closing occurred. Directly I am checking in the dictionary. Initially list is empty. Then how do you pop? If the list is empty, it is not possible to pop. If L, that means true. L in the sense true. True means it consists of at least one element. The output is true. Then only do pop operation. Otherwise, use any symbol. Not only hash, you can use any symbol. Now I am getting X value. If X value is not equal to D of I. What is D of I? Opening is not equal. Then no need to compare the remaining one. Simply you can return the false. Once to come out of the loop, what you return? Return not L. Why not L? Suppose list consists of any one element. Output is true. Not L means the false. Finally, after completion of entire string, if list consists of one element in the sense, it is not allowed. At one element in the sense, it is not allowed. Clear? All the list must be empty. Accepted. Submit. So clear? Now, in the next session, we will move to one more program. Okay. This is valid parenthesis. Thank you.